Imagine, imagine spending like $100,000 on this massive state-of-the-art website redesign,
Oh, yeah.
right? And you launch it and everything looks beautiful, but then you realize that every single time your marketing team changes, like a product category name, your entire website's navigation just completely breaks.
Shatters.
Exactly. Returning just endless 404 errors for your users. And yeah, I think people assume that's a rare hypothetical nightmare scenario, but I mean, it happens every single day.
It really does. It happens all the time.
Because all too often, enterprise companies treat their headless CMS like just this chaotic digital dumping ground, instead of a highly structured relational ecosystem. So welcome to the deep dive, everyone.
Glad you could join us.
Yeah, we are so glad you're here with us because today we're tackling exactly that problem.
It's the classic trap of digital scaling, really. You focus so much on the presentation layer, like how the site looks, how the content reads.
The flashy stuff.
Right, the flashy stuff. And you completely neglect the data layer underneath. And when you're generating just exponentially scaling amounts of content, I mean, we're talking thousands of products, blog posts, regional variants. The lack of an underlying architectural language doesn't just make the platform inefficient. It actually makes it fundamentally fragile.
Okay, let's unpack this. Because going from a fragile, hard-coded mess to a beautifully organized, dynamic ecosystem, it requires mastering some very specific foundational tools.
It really does.
And that is our mission for today's deep dive. We are looking directly at the architectural heart of Contentstack, which is taxonomy. And, for those of you listening, we're assuming you understand the basics of headless architecture.
Right. We're not starting from absolute zero here.
Exactly. We aren't here to, explain what a CMS is. We're here to explore the database logic, the API architectures, and the complex developer workflows that make taxonomy the absolute foundation of your digital implementation.
Yeah, and it's vital to frame taxonomy correctly right from the jump, I think. Because a lot of people misunderstand it.
Oh, for sure. How do they usually get it wrong?
Well, they think it's just a feature you toggle on. Or, they think it's just some superficial tagging system for SEO.
Just typing in some keywords and hitting save.
Exactly. But it's not. Taxonomy is the structural language your digital implementation uses to actually understand its own content payload.
Wow, okay. The structural language.
Right. When a front-end framework queries the Contentstack API, the taxonomy is what tells that API how pieces of content relate to one another. I mean, without it, your database is really just serving up isolated, disconnected blobs of JSON.
So it's basically the Dewey Decimal System for our digital brains.
That is actually a really great way to put it, yes.
But, let me ask you this. Is setting this up early really that necessary?
Yeah.
Or can a business just, wing it and organize later once they have more content?
Oh, you absolutely have to do it early. If you try to retroactively apply the Dewey Decimal System to a library where you've just been throwing books into a giant pile in the middle of the room for 3 years...
This is a total disaster.
It's an absolute nightmare. Doing it early is crucial because it solves so many real-world production problems right out of the gate.
Right. Which brings us to the actual tangible use cases.
Yeah.
Let's talk about what this actually does for the user experience. Because we all know how vital breadcrumbs are, for helping users trace their path.
Oh, absolutely. Especially for blogs or e-commerce sites where you need to know exactly where you are in the catalog.
Yeah. But historically, developers had to, hard code those routing paths, right?
Mm-hmm.
Or they had to build these incredibly fragile custom scripts to try and generate them.
Yeah, and that's where a centralized taxonomy just completely flips the workflow. Because instead of your front-end developers writing, manual routing logic, Contentstack dynamically maps the taxonomy hierarchy directly to the front-end router.
Oh, wow. So the system just knows.
Right. The breadcrumb basically generates itself based on the system's underlying structure. So if you have a taxonomy tree that goes, let's say, men's, and then down to shoes, and then down to sneakers,
okay,
the API payload delivers that exact relational path. The front end just receives it and renders it.
So it completely removes the engineering team from the content routing business entirely.
Yep. They don't have to touch it.
Which, that ties directly into dynamic URL generation too, right?
Exactly.
If the taxonomy is driving the breadcrumb, it's also dictating the actual web address.
Yeah.
So the URL dynamically builds itself as yoursite.com and shoe sneakers strictly by reading the taxonomy hierarchy attached to that specific entry.
Precisely. And the downstream effects of that are just massive for SEO and site maintenance.
Because it stays consistent.
Right. If a developer maps the page URL directly to the taxonomy hierarchy, you guarantee that your site's physical URL structure perfectly mirrors your database structure at all times.
There's no drift.
Exactly, zero drift. There's no drift between how the business categorizes a product internally and how a search engine crawls it externally.
That is huge. And, when we look at advanced search filters, like those faceted sidebars you see on complex media sites or online stores where you're filtering by brand or size or color or whatever.
Yeah, the sidebar filters.
Right. That's just another manifestation of this same taxonomy architecture, isn't it?
Yes, exactly. Faceted search relies heavily on the Content Delivery API, or the CDA.
Okay, the CDA.
Right. So when a user clicks a filter box on the front end, the site isn't actually doing like a raw text search through every article.
Oh, it's not.
No, it's sending a highly specific query to the CDA asking, retrieve all entries bound to this specific taxonomy UID. And because the data is strictly structured, the payload comes back instantly.
That makes so much sense.
Yeah.
But I do want to push back on something here, or at least explore the edge of where this gets a bit complicated.
Sure, let's hear it.
Because the source material also mentions that this architectural setup allows for multi-brand management within a single stack.
Yes, it does.
And the idea is that you manage, say, a luxury tech brand and a budget tech brand from one single content stack environment, right? Just using a brand taxonomy to dictate access and API content delivery.
Yeah, it's an incredibly powerful headless multi-tenant architecture. Because historically, if you had two distinct brands with two distinct front ends, you basically built two entirely separate CMS environments.
Which means double the work.
Double the logins, double the API integrations, double the maintenance, just double everything.
Right, an operational nightmare. And the solution proposed is using a single stack, but relying on a brand taxonomy to filter the content. So developers use the taxonomy to essentially wall off content for brand1.com from brand2.com. But here's where it gets really interesting. If I have multiple brands in one stack, isn't there a risk of content bleeding over? Like, if you're walling off editor A into brand 1 and editor B into brand 2 using these taxonomy permissions, what happens to, like, global shared assets?
That's a great point.
Say you have a standard corporate privacy policy or, I don't know, a massive Black Friday banner that needs to run on both domains. Doesn't creating a strict taxonomy silo actually force you to duplicate shared assets, which kind of defeats the whole purpose of a single stack?
Well, this raises an important question about governance models. And it's the exact trap architects fall into if they view taxonomy as like a rigid physical folder rather than a relational tag.
Okay, so it's not a folder.
No, taxonomy in a headless environment doesn't physically trap an asset in a box. It applies a relational reference. So for a shared asset like that Black Friday banner you mentioned, you simply tag that single asset with multiple taxonomy terms.
Oh, I see. So you tag it with brand 1 and brand 2.
Exactly. The asset exists only once in the database, maintaining your single source of truth. But because it carries both taxonomy UIDs, the API endpoint for the luxury brand can successfully fetch it, and the API endpoint for the budget brand can also fetch it.
That's brilliant.
Yeah. And meanwhile, editor A and editor B both have custom roles and permissions to view it within their respective workspaces. So you bridge the walled gardens without duplicating a single byte of data.
That makes a lot of sense. So the taxonomy acts more like a selective membrane, not a concrete wall.
Exactly.
So having established what taxonomy can do externally for the user, if we look at how this impacts the internal philosophy of content management, it really seems to enforce a shared language across completely different departments.
It does. At a high level, taxonomy is the systematic categorization of your digital ecosystem. It enforces strict categorization based on your business requirements.
Right.
When you organize your web properties by, say, target audience or content purpose through a centralized taxonomy, you effectively eliminate the operational silos that usually plague large teams.
Let's use the e-commerce example from the source to illustrate this.
Sure.
Imagine you're building a massive digital storefront for a global retailer. You establish a primary taxonomy. You have broad categories, right? Like electronics, which branches into smartphones, laptops, and cameras.
Right.
And then you have clothing branching into men's, women's, and kids. Home and kitchen branching into furniture, appliances, and cookware.
Think about the data standardization that achieves across a whole company.
Yeah.
A developer writing a GraphQL query to pull the latest products for a specialized landing page is utilizing the exact same hierarchical logic, the exact same UIDs as the content editor who is uploading the product images and writing the marketing copy.
Oh, wow.
Yeah. And the data science team, they're analyzing user flow through the cookware section, and they are tracking the exact same structural definition. There's no translation layer needed between engineering, marketing, and analytics because the taxonomy is the universal translator.
I see the architectural beauty in that. I really do. But I have to play the skeptic for a second here.
Go for it.
Because this sounds highly structured, almost like rigid. If I'm a highly creative content editor, doesn't this strict hierarchy box me in? Like if I'm managing an editorial blog and I need to react quickly to cultural trends, does having the developers dictate the taxonomy stifle my editorial agility?
You know, it's a very common fear when implementing strict data governance, but the reality is actually the exact opposite.
Really? How so?
Structure at the data layer liberates the presentation layer. Without a strict taxonomy, that creative editor spends like half their day just doing administrative chaos management.
Oh, it's true?
They're trying to figure out where a post should logically live. They're manually typing out SEO metadata routes. They're constantly messaging developers, asking them to update navigation links so their new article actually appears on the homepage.
So they're basically doing database administration instead of actually writing.
Exactly. But with a centralized taxonomy, all of that routing, the URL generation, the breadcrumb mapping, that is all handled autonomously by the system based on the taxonomy rules. The editor simply writes the piece, selects smartphones from an intuitive drop-down menu, and hits publish. That's it. The APIs read the taxonomy, route the content to the correct endpoints, update the navigation, and build the URL. The strictness of the back-end architecture is what allows the front-end user to just move fast without breaking things.
Okay, I love that. They don't have to build the shelf. They just get to write the book and trust that the system will file it correctly.
Exactly.
So if we establish that this structure is non-negotiable for scale, we need to look at how a team actually architects it within Contentstack. Like, how do you actually start building this liberating structure?
Well, the creation process is heavily centralized by design, right? You want to prevent rogue categorizations from muddying the database. So centrally managing it is key. You build a container first.
Right. And while we won't walk through like every single UI click here, we assume you listening know how to navigate a settings menu, the source documentation does give us the exact step-by-step process.
Yeah, and they even provide video walkthroughs to visually anchor users, which is super helpful.
It really is. So basically, you log into Contentstack, you navigate to your stack, and you click the settings icon. Oh, and wait, there's a keyboard shortcut mentioned here too.
Yeah, you literally just press S.
Just the letter S.
Just S, and it opens the settings.
Oh, I love that. Small things like that save so much time.
They really do. So from settings, you select taxonomy, click R plus new taxonomy, and you enter a name and an optional description. You can also do this programmatically via the Create a Taxonomy API, by the way.
Okay, simple enough. But here is the critical architectural concept we really have to dissect.
Yeah.
The UID.
Oh, yes. The UID.
Because when you create a taxonomy and enter a name, the system auto-generates a unique ID, or UID. And the vital rule here, and I cannot stress this enough based on the docs, is that once you save that taxonomy, the UID cannot be changed. Ever.
Yeah, we really need to dive deep into the permanence of the UID because this is where a lot of teams make foundational errors.
Why does Contentstack lock it down like that?
It's not an arbitrary restriction. It's because the UID is the foundational hook for all APIs and relational references in the system. The APIs use the UID to query data. The front-end framework uses the UID to build dynamic page routes. The reference fields in your content models bind to the UID.
So if you could easily just edit the UID, you would instantly sever every single one of those database reference links.
Yes, you would orphan thousands of entries and essentially crash the front-end application because the API would be looking for a data node that just no longer exists.
So the name is the paint job on a car, but the UID is the VIN number stamped into the engine. You can repaint it, but you can't change its core identity.
That is a perfect architectural metaphor. Because the UID is immutable, the mindset a team must have during this creation phase is one of extreme foresight.
They have to anticipate future growth.
Right. You cannot treat taxonomy creation as a quick fix for a temporary problem. If you name your taxonomy container Summer Promo 2024, that specific string Summer Promo 2024 is locked into the codebase forever as the UID.
Then when next summer rolls around.
You are stuck with outdated technical debt at the database layer, so you have to name your taxonomies thoughtfully. You have to think structurally in universal concepts, not temporal ones.
Okay, that makes complete sense.
Yeah.
But that analogy about repainting the car transitions perfectly into what happens when a business does need to change its outward appearance.
Right.
Because markets evolve.
They absolutely do.
Let's say you built a massive structure 3 years ago, and the presentation name you chose was Tech Gadgets. But today, the business is pivoting. User testing shows that Tech Gadgets sounds outdated, and the marketing team demands a full rebrand to smart home devices.
A very common scenario.
Right. So how does the platform handle that front-end evolution without breaking the back-end stability you just talked about?
Well, this is where Contentstack allows you to easily edit a taxonomy to suit those changing needs. You just go to Settings, then Taxonomy, you identify the taxonomy, click the ellipsis, the 3 dots in the Actions column, and click Edit. Here, users can update the taxonomy's human-readable name and description. You change the text string from Tech Gadgets to Smart Home Devices, and you click Update to save. And again, there's a dedicated video walkthrough for this in the docs.
And because of that decoupling, what actually happens under the hood?
What's fascinating here is how Contentstack decouples the human-readable labels from the machine-readable IDs. It protects the architecture from human indecision. The content editors instantly see the new name Smart Home Devices in their UI dropdowns.
Right.
The front-end application instantly updates the website navigation to say Smart Home Devices. But critically, the underlying UID remains exactly what it was on day one Tech Gadgets.
So the engineering team doesn't have to touch a single line of code.
Not a single line. They don't update their GraphQL queries, they don't rewrite routing logic, and no reference links in the database are broken. Editing metadata without disrupting stack architecture is just a massive advantage for agile businesses.
Okay, but if I just have a taxonomy named Smart Home Devices, it's basically an empty file cabinet, right? When do we put the actual files in? How do we build out the granular routing logic?
Well, the taxonomy is just a container. You populate that container by creating terms. The taxonomy without terms isn't really doing much for you.
Okay, so what exactly are terms?
Terms are the primary classification elements inside the taxonomy container that establish the actual hierarchical structure. They are the actual tags you use.
So how do we create them?
You walk through a very similar path. Settings, then Taxonomy, select your taxonomy and click plus new term.
Okay.
You enter the term name, and just like before, the UID auto-populates, though it is editable right before saving.
Got it. And the source gives us some really great illustrative content here to explain the hierarchy.
Yes, let's look at those.
It mentions a superhero taxonomy, right? And inside that container, the terms are things like origin and powers, natural powers, mystic origins, scientific experimentation, and superstrength.
Exactly. Or an animals taxonomy, where the terms would be mammals, birds, reptiles.
And the UI allows for 2 distinct relational choices when creating a term: sibling term or child term. What is the difference there?
This is crucial. When you build terms, you are physically building the tree-like structure of the data. Let's use the genre taxonomy example from the source.
Okay.
Let's say you create a term called fiction. That is your top-level node. If you want to add nonfiction, you create a sibling term to fiction. They sit on the exact same hierarchical level.
They share the same parent, which is the taxonomy container itself.
Right. But if you want to get granular, you create a child term. So under the sibling term fiction, you create a child term called historical fiction.
Oh, I see. So nesting terms as children physically builds the relational dependency links.
Exactly. Content creators will eventually use these specific terms to tag entry items, making filtering and searching vastly easier.
So what does this all mean for the person actually writing a blog post? Are they dealing with all this back-end sibling-child stuff?
No, they aren't thinking about nested data structures at all. For the writer, it just looks like a clean, logical drop-down menu in their workspace. They see fiction, they see historical fiction under it, they click it, and they're done.
It's totally frictionless.
Exactly.
But just like language evolves, the labels on those drop-down menus might need to change, right?
Oh, absolutely. Terminology changes over time.
So does the system give us the flexibility to edit terms, just like we edited the taxonomy name?
Yes, the fundamental architecture is identical. The steps are straightforward. Settings, taxonomies, choose the specific taxonomy, locate the exact term, click it, update the name on the term details page, and click update.
The source gives a specific example of this, locating the term historical fiction, which, remember, lives under the parent term fiction, and updating its name to historical old fiction.
Right. And why might a company do this? Well, maybe search trends show users are actually looking for old fiction, or an internal audit revealed the need for broader categorization.
But here is the massive operational question. If I change historical fiction to historical fiction, do I have to go back and manually retag all my old blog posts? Like, what if I have 5,000 articles tagged with the old term?
If we connect this to the bigger picture and the database logic we discussed, no, you don't have to touch a single entry.
Really?
Really, because the content is tied to the term's underlying identity. The permanent UID updating the term's name dynamically updates how it is classified globally. No manual retagging required.
That is such a relief.
It saves hundreds of hours of manual labor.
But what happens when an entire category becomes completely irrelevant to the business?
Yeah.
Like, we don't just want to edit it, we want to delete it entirely to keep the architecture clean.
Well, deleting obsolete terms is necessary, but it introduces significant risk. The steps are easy. Settings, taxonomies, choose a taxonomy, select the term, click the ellipsis on the top right and hit delete term, then confirm.
Simple enough UI.
Aye.
But the source has a major caveat here, a crucial rule.
Yes. Deleting a parent term automatically deletes all of its child terms.
All of them.
All of them, instantly. If you delete fiction, it automatically deletes historical old fiction along with it.
Wow. It's like pruning a tree. If I cut off a thick branch, I'm losing all the little twigs and leaves attached to it, whether I meant to or not.
That is exactly right. It keeps the system clean by preventing orphaned data, but it is a destructive action that requires extreme caution.
So how does a team safeguard against accidental pruning? Like, what if an editor just clicks delete by mistake?
Well, you control that with permissions. But while any authorized editor might be able to prune a branch, delete a term, cutting down the entire tree, meaning deleting the taxonomy itself, requires much higher clearance.
Okay, let's talk about that final step in the life cycle, deleting redundant classification systems.
Sometimes a project ends or a whole system is obsolete, and you need to delete the taxonomy. The steps are settings, taxonomy, click the ellipsis next to the taxonomy, and click delete.
But there are vital security guardrails here, right?
Yeah, huge guardrails. First, when you click delete, a modal pops up, and you literally have to type the word delete in all caps to confirm.
It forces you to pause and think.
Exactly. And second, only the owner or an admin of the stack can delete taxonomies. Standard users absolutely cannot delete taxonomies created by other stakeholders.
Because the consequences are massive.
Permanent deletion, removal of associations with all content types, and the deletion of all internal terms. Any API endpoint relying on that taxonomy will break.
It's the digital equivalent of launching a nuke. You need two keys turned at the same time by the top brass.
Exactly. Contentstack puts those friction points in place to prevent catastrophic data loss.
Wow. We have covered an immense amount of ground today.
You really are.
Just to briefly summarize our journey, we started by understanding the philosophy of taxonomy as the structural language of your CMS, not just a tagging system. We looked at its powerful use cases, from generating breadcrumbs and dynamic URLs to driving advanced search and enabling multi-brand walled gardens without duplicating assets. Then we walked through building the actual containers, understanding why the UID is permanently locked while the human-readable names can adapt. We fleshed out the hierarchy using sibling and child terms, saw how editing dynamically updates globally, and finally, learned how to safely demolish it all when necessary, avoiding the trap of cascading deletes.
It's a complete life cycle.
It really is. But I want to leave you, the listener, with a final provocative thought to mull over based on everything we explored today.
Oh, I like these.
We've learned that UIDs are permanent, etched in stone, but terms, names, and even entire taxonomies can be edited or deleted as a business evolves. So, in an era where digital content is scaling exponentially and market trends shift overnight, how do you design a foundational taxonomy today that is structured enough to govern your data, but flexible enough to survive your company's inevitable pivot tomorrow?
That is the ultimate challenge for any content architect. It's a great question.
It really is. Well, thank you so much for joining us on this deep dive. We hope that the next time you look at your CMS, you start mapping out a beautiful structural ecosystem.
Thanks for listening.
We will catch you on the next deep dive.